and you found the quick review. And I want to take a look at the remainder theorem. And the remainder theorem is useful in determining if a binomial is a factor of a polynomial. Okay, so it goes like this. If I had the factor x minus 3, is it a factor? Well, I can do long division and see if I get no remainder. But the remainder factor will allow me to do it a whole lot more quickly. So I'm going to use f of 3. Now you say, why is it 3? You have x minus 3. Well, again, technically you're supposed to set this thing equal to 0 and therefore find out that an x minus 3 factor is when the x value is 3. Okay? So I'm using f of 3 to see if x minus 3 is a factor. And what I'm looking for is a 0 remainder. All right, so everywhere where the x is, I'm going to sub in my 3. All right, so everywhere where x is, sub in 3, sub in 3, sub in 3. Okay, 3 cubed. 3 times 3 is 9, times 3 is 27, times 2 is 54. 3 squared is 9, times 11 is negative 99. 16, 32, 48 minus 3. All right, let's see how many positives. 54, 94, 102 positives, and look at that, 102 negatives. And what's our remainder? 0. And because I got a 0 remainder, I know that x minus 3 is a factor of this polynomial. Now this is a means to an end. I would then use long division, divide it into the original, and finish off from there, either finding zeros or finding values of the polynomial or being able to graph. Okay, so just one more thought here. Remember, if you have something like an x plus 5, then again you would try f of negative 5, because again it's x plus 5 equals 0 and x equal negative 5. So just don't forget that. If you forget that, then you're going to be in some trouble there. Okay, so I know that is a factor, and therefore now I'm able to use that factor. All right, so that's in the nutshell the remainder theorem, and no need to go the time-consuming aspect of long division. The remainder theorem is much quicker in determining whether something is a factor of another polynomial. Okay.